So we're in 3.5, and we're going to look at question number 9. Okay, and we're going to try to graph this function. So we've got f of x equals 5x over x minus 5, x minus 1. So for this, remember, we have a step-by-step procedure. And so the first thing that we're going to do is we're going to try and find our asymptotes. And we'll do the vertical one first, and then we'll do the horizontal one. Now remember, for the vertical, you can have more than one. In many cases, you may have one, you may have two, or you may have none at all, depending upon the function itself. And how do we find the vertical asymptote? We set that denominator to 0. Now this one has already been factored. And so when we set that to 0, that gives you then x minus 5 equals 0. So one of the verticals is 5. The other one, x minus 1 equals 0. Well, that gives you x equals 1. So we now have two verticals. What we're now going to look at is we're going to look at our choices. We're going to look at our graphs. And I made these multiple choice on purpose so that they would be a lot easier to graph, because they are kind of time-consuming and tedious. Sometimes they're confusing as well, but we're going to go through and we're going to see which one of the choices it is. And we're going to begin by using the process of elimination, and we're going to see which ones we can eliminate. Okay, so there's our original function. Now I think I can eliminate a. And I can eliminate a because it looks like that vertical's at what? Minus 5, and that one's at about 1, isn't it? And our verticals are supposed to be at what? Our verticals are supposed to be at 5 and 1. So just by process of elimination, a is gone. Now b looks like it could work, right? Because it looks like it has a vertical right about here. They don't put the dotted line in, but that dotted line would be right about there. So that one could work. What about C? Can it work? Yeah, it looks like C looks like it can work too, doesn't it? Right? Because there's your 6, and there's your 5 right there and there, so it could work. What about D? Well, D can work as well. So now we have eliminated one of the choices just by doing the verticals. Next, we need to find our horizontal. And when we get the horizontal, we're going to go ahead and FOIL this out quickly here. And then we'll see what we've got. So I'm going to take that 5x. I'm going to leave it alone on the top. I'm going to go ahead and FOIL out this denominator, and so that is then x squared, right? Minus 5x minus x makes it a minus 6x plus 5. And how do we find our horizontal? Okay, for the vertical, remember, what did we do? For the vertical, we set that denominator to 0, right? Now, for the horizontal, what do? We divide by our highest power of x, right? Remember that from last time? Okay. And we let x go to infinity, and we see what happens. Now, everything that does not reduce down to a whole number is gone. It's going to be replaced with 0. So let's go ahead and divide everything by our highest power. In this case was an x squared, because that came from FOILing that out there. So we're going to go ahead and rewrite this now as 5x over x squared. And then we've got x squared over x squared. We've got a minus 6x over x squared. And then we have a 5 over x squared. Now, as x goes to infinity, what is going to happen is everything that does not reduce down to a whole number is going to be gone. Okay, so a lot of these are going to go away. Well, 5x over x squared, that doesn't reduce down to a whole number, so that's gone. However, x squared over x squared reduces down to 1. That's gone, and that's gone. So what's left over is 0 over 1, which is then what? 0. Okay, so our horizontal is going to be y equals 0. That's a horizontal asymptote. Now, just by getting the vertical and getting that horizontal, we should be able to eliminate probably 2 more choices. Maybe just 1, but at least 1 more, maybe 2. We might be able to get the answer just by finding the ones that have the horizontal at 0. Okay, so let's see if we can eliminate 1. And unfortunately, I don't think that we can. Okay. A is already gone, right? We eliminated A. B still has a possibility. Why does B have a possibility? It's not really shown here, but notice how this graph goes to what? As we slide down, that goes to 0. So it looks like it has a horizontal there at 0. So B is still a viable option. What about C? Does it look like it goes to 0? Yep, because here it crosses and slides back up. So it's going to 0. Same thing here. So this one also. Still a possible choice. And same thing with C. Right? Pops above it, goes back down. So C and D are still choices. So we've got one of the answer choices eliminated. So we found our vertical, we found our horizontal. Now we can find our intercepts, and that's going to get rid of another one. So we have our vertical, we have a horizontal. Now let's find our y-intercept. And how do we find that y-intercept? Well, to find the y-intercept, remember we use x equals 0. So we're going to plug in 0. And we're going to see what we get here. And the numerators, 5 times 0 is still 0, so that's gone there. It's still 0. 0 minus 5 is a minus 5. And 0 minus 1, well, that's a minus 1. When you multiply, we get 0 over, it looks like positive 5, right? Just negative, negative makes it positive. And 0 divided by any number is still what? Still 0. So now we have our y-intercept at 0, 0. So let's see if we can eliminate some choices here. We should be able to hopefully at least eliminate one more of these. Okay, I can eliminate B. Why can I eliminate choice B? Well, when I look at my picture here, look at the y-intercept. Okay, the y-intercept needs to be at 0, 0. Well, this is not at 0, 0. This y-intercept is at 0, 1, isn't it? Right? Because it looks like your picture crosses right there. So what do we know about B then? B's gone. Because it has to go through 0, 0, the origin. Let's see about C and D. See if we can eliminate either one of these. All right, well, it looks to me like C still works because it still has 0, 0, doesn't it? And same thing with D. So we're now down to 2 choices. Okay, now we'll move on to the next step. And we just keep going until we can finally graph our equation here. So we're going to move on to the next step here. So that was the y-intercept. Now we're going to find the x-intercept. How do we find the x-intercept? Well, we set f of x equal to 0. So we're going to set f of x equal to 0. And so that is then 5x over x minus 5, x minus 1, okay, equals 0 over 1. And we're just going to simply cross multiply. And when we do that, we have 5x equals 0. So that gives me x equals 0 again, which is the same 0.00. So it should never cross the x-axis at all, except at that 0, 0. So let's look and see what we've got here. Okay, neither one of them cross the x-axis at anywhere except that 0, 0. Right, that one's right there at 0, 0. That one crosses right there at 0, 0. So those two are still viable choices. Now, what do we need to do after this? Well, we found our intercepts. We found our asymptotes. Right? We've got it down to two choices. We need to figure out which one it's going to be. So we need to figure out where it crosses, if it does, the horizontal. So you now set f of x equal to the horizontal. And what was our horizontal? If we go back and look, our horizontal was 0, and we just did that. Right, we just did that. So again, we did that a moment ago, okay? That was the last step that we just did. And that was still equal to 0 again. So we just did that, and that's 0, 0. So that's where it can cross the horizontal. And should not cross anywhere else. And it looks like that's the only point at which it does, and they both do that. Right? 0, 0, 0, 0. Okay, so now we're almost finished. We need to look now at these two choices. So we've got it down to two choices. How do we figure out which one it is? What's the difference between these? We need to only find one difference, and once we find one of the differences, that's going to tell us which one it is. Okay, let's look here. On C, this side is what? This side is positive, right? So this is going to be positive. So let's pick a point. Here's our vertical after 5. So let's pick 6 and see if 6 is here or if 6 is down there. So all we need to do now is pick one more point, and then we can use our process of elimination to finish it. This one's quite a bit more difficult than 10. 10 is quite a bit easier. This is the hardest one. Okay, but you see the difference. This one's up and this one's down. So let's pick a number bigger than 5. So that's going to be far to the right here. So let's pick 6. Okay, so we're going to check x equals 6. So we're going to plug that x equals 6 back in. And we're going to see what we get. And then that's going to tell us which choice it is. 5 times 6, well, that's 30. 6 minus 5, that's a 1. 5 minus 1, that's a 4. And that's 30 over 4. So what's my new ordered pair look like? Remember, this is your x. X is going to be 6. Why is that 30 over 4? Now, what's 30 over 4 in our calculator? I believe that should be 7.5, right? Oh, yep, sorry about that. You're right. Yep, 6 minus 1, my mistake. And 6 minus 1, that's going to make that a 5, won't it? Sorry about that. And that's going to make that a 5. And 30 divided by 5, that makes it then a 6, doesn't it? Okay. Now, what's our point? 6, 6. So, let's look at our choices. Again, we are down to these two choices. It looks like D is not going to work, right? Because D, where's 6, 6 at? Okay, well 6, 6 would be 6 here and about there. Is that on my graph? No. So D is done. What about part C? Well, if we look at part C, yeah, it looks like right there is 6, 6. That's on your picture. So the answer for that question is going to be what? C. Again, I made them multiple choice because I know it takes a really long time to go through and finish them out. If we wanted to completely graph this out, we would pick some more points in the middle, and you would see how it would make a squaring function opening down here, and then we'd have our cubes on the side here. So we used process of elimination to find out that the answer for 9 is going to be what? C. Now, 10 is substantially easier. So 10 is going to require a lot fewer steps. X plus 5 over x plus 4, okay, quantity squared here. So, what are we going to do for 10? Well, we're going to go through the steps. First thing we're going to find is the verticals. Those are usually the easiest to do, and so I find them first. So I set that denominator to 0. And how do we get rid of a square? Does anyone remember what we use? We use the square what? Square root, okay? And 0 is not signed, so it just goes away. And leaves you with the 0. So that gives you x plus 4 equals 0. So now our vertical is x equals what? -4. Okay. Now, I know I kind of worked on this with the other class because they asked about it last time. But why can I eliminate answer A? Why is A not going to work? Does A have a vertical at 4? At that -4? No. Right? It would need to have something here. This one doesn't. This one doesn't even have a vertical at all. So A is clearly not an option. What about C and D? Well, they could be, right? Because this is going to be back here somewhere about -4. And same thing with D. So we have eliminated one of them already. Now let's try to find the horizontal. And we should have one. So I'm going to go ahead and distribute that x through and square out that x squared plus 4. So that's going to give you, if I distribute it through, an x squared plus 5x over x squared plus 8x plus 16. Now, when we find our horizontal, what do? We divide everything by the highest power, which is going to be what? X squared, someone said it. So let's go ahead and do that. And then this is going to help us eliminate another answer choice or two. Okay, so I did that. And what's going to happen? Well, x squared over x squared, what does that reduce down into? That's your 1. X squared over x squared here is also 1. That goes, and that goes. So what are we left with? 1 over 1, which is then 1. So what is our horizontal? Y equals 1. Okay. That should help us eliminate at least one more choice. I think it can actually get rid of both of them. Now, is B going to be a viable option? I think B can work, right? Because B looks like our horizontal is right here about 1. Okay, right? It looks like if we were to add in the dotted line, that one could work. Now, what about C? C doesn't even have a horizontal. Okay, it's got what's called an oblique. We don't even discuss obliques in this course because I think they're a little bit too much. So C doesn't work at all, right? Because it's an oblique. It's on the diagonal. What about D? Why can D be eliminated? Well, look at your horizontal here. Okay, this side, where is it going? It's going here, but look at my dotted line. Where's my dotted line at? Our horizontal line, our dotted line here, is at what? -1. So D doesn't work either. So which one have we got it down to? We used process of elimination to get this now down to be what? B. And you could keep going. You could find your intercepts as well, like I did here. Okay, you could find your intercepts. Basically, what you do is just keep going through the steps until you get enough to pick out the correct graph. Because you can use process of elimination. I'm not going to make you graph these completely out because that would be another 15 minutes to pick the points and curve them all. The main thing is process of elimination. Find your verticals, your horizontals. Maybe find the intercepts if you need them. Okay. And I'd be able to identify everything from the graph. So that's the important parts here. So the answer for 10 should be then what? Should be B. Okay. Did we have any other questions out of 3-5? I think all the others are quite a bit easier. Anything else out of 3-5 to look at? Can we get all the others? Yeah, the others should have been a lot easier to understand and graph. Well, if we don't have any other questions, then we'll go ahead and start the new section. So I'll pass out the new homework packet. Get the new homework packet passed out here. And today we're going to be looking at 3-7. There's a lot of sections in chapter 3 that we just really don't cover because they're not necessarily part of our outcomes and objectives. And a lot of chapter 3, it's not really difficult. It just takes a really long time. And I don't think you can spend a really long time graphing out different polynomials. So we don't do a lot of chapter 3, we do part of it. What we're going to be looking at today is variation. And what variation is how things relate to other things. And an example of that would be like the effects of gravity on how hard a ball hits the ground. So, the harder I throw a ball, right, the harder it's going to hit the ground. Those directly relate to each other. I throw it up in the air, it's got to come back down. And we have a gravitational constant, 9.8 meters per second. And that comes from calculating it out using variation. And variation questions are not difficult. It's just setting up different ratios. When we do these variations, okay, we have to find our constant. Now, what do I mean about a constant? Something's a constant like gravity. Okay? Now, when we talk about gravity, gravity is different on Earth versus the moon, right? Different gravities. So the constant is not always the same. Depends upon the environment. Gravity is different on the moon than it is on Mars or on Earth. So what we look at on these is we have to find our constant. Now, another constant could be pi. Right? Pi is another constant. When you look at a circle and you figure out the circumference, it has pi involved. Pi is just a constant. This is how they came up with the gravitational constant, pi, and everything else, is they did experiments and they used what's called variation. And what happens is one part relates to another. And they go together either directly, inversely, or in some cases, joint variation. These are all applications, but they're actually very easy. It's just a matter of making sure that we understand how to set them up. And we're going to learn first direct variation. And what direct variation means is one thing affects something else. Okay? So, the faster I go, the longer it's going to take to stop the car, right? Higher the speed, longer the time it takes to stop. That's just common sense. One thing relates to the others. And like in that example, your K, your constant, might be something like the tires. Tires make a difference. Different tires help the car stop faster or slower. So when we look in this section, we're going to be looking at variation, and different components relate differently together. And the first one we're going to look at is direct variation. And this is 3.7. And we're going to look at direct variation. And direct variation just means one influences another directly. So increase one, you increase the other one. And this is our formula for direct variation. For direct variation, y equals kx. And that's our formula for direct variation. Now, k is the constant, and that's what we have to find. So k is going to be our constant, and we're going to have to find it. Now, when I work these out, I use words instead of the variables in many cases because it's confusing if I put in the y's and the x's. Then we forget what is what. So when we work these out, okay, I'm going to use words instead of the variables. Except for k. K is going to be our constant, and we're going to have to find it. And so we're going to look at these applications, and these are direct variation. So I'm on page 416, and we're going to look now at question 27. And this one deals with pi. We're going to be finding pi here. Actually, 2 pi. The circumference of a circle varies directly as the radius. So as the radius increases, that means the circumference is also going to increase. A circle with a radius of 7 inches has a circumference of 43.96 inches. Find the circumference of the circle if its new radius is 11 inches. Now, the key words here are varies directly. And what do we have? Circumference, and we have the radius. So we're going to set up our equation to look like this. The first part we get is the circumference. And the circumference here is going to equal k, which is our constant, times the radius. That's our formula. So the circumference varies directly to the radius. So that's why the circumference is here. It's listed first. Radius is on the other side. Now, what are you given? When we read this, it says a circle with a radius of 7 has a circumference of 43.96. So in this case, r is going to be our radius. We'll just write out radius here. Radius is 7, circumference, and I'll just abbreviate that. Circumference is the 43.96. And now we plug our values in and we find our k. So we come up with our equation, we plug the values in that they give you, and we find our k. So that's 43.96 equals k times the 6. And we want to go ahead and find our k. So we divide by our 6. And what does, 7, my mistake here, not thinking today. Okay, we're going to divide that by our 7. And what does that give you now? When we find that, that's going to give you k, and we'll get this out to 2 places. So let's find our k, and we'll talk about what it is. 43.96. We're going to divide that by our 7, and that comes out to be 6.28. And that's our value of k. Now, what is that? That is 2 pi, right? Pi is 3.14. Circumference has 2 pi in it. 2 pi, that's your constant. And that's your 6.28. So that's where 2 pi came from, by working out a question like this one. Now we can rewrite our formula. So now we're going to rewrite this as a circumference is equal to 6.28 times the radius. Now we're going to change it. So we rewrite our formula with the new k. And what do we want to now find? It says find the circumference of a circle if its radius changes to 11. So now our radius is going to be changed to 11, and we have to find our circumference. Well, that would be 6.28, right, times 11, and that comes out to be our new circumference. So 6.28 times 11. And we're going to round here, and that comes out to be 69.08, and that is in terms of inches. So that is your new circumference for a circle with a radius of 11. Now we found k, and in this case, k happened to be 2 pi. And that comes from the formula for the circumference of a circle. Let's do another one. Question 30. And they're all pretty much the same. It's just making sure that we can set them up. So question 30. So question 30, we're looking at the weight on the moon. The weight of an object on Earth is directly proportional to the weight of that same object on the moon. A 200-pound astronaut would weigh 32 pounds on the moon. How much would a 50-pound dog weigh on the moon? So the weight of an object on Earth is directly proportional to the same weight of that object on the moon. So our formula is going to be the Earth weight is going to equal k times the moon weight. Now, what are we going to plug in here? Okay, it says the weight of an object on the moon. So a 200-pound astronaut, so that means that astronaut on Earth would weigh 200 pounds, weighs only 32 pounds on the moon. So we're going to plug that in, and we're going to find our K. So that's what we need to do. Set up our ratio. We can use the Y and the X, but I think it's confusing, and students get all mixed up. So I would rather write it out in words, plug the words in, and make our formula off of that. I think it's way, way less confusing. So Earth is 200, K times the moon, which is 32, and we're going to divide by that 32. We're going to see how far we can reduce this down. You can either use a decimal or a fraction. It really doesn't matter. I'm just going to go ahead and reduce that down. So if I reduce that fraction down, it looks like it's going to be 25 over 4. If I reduce it down, by a factor of 8, because 8 should go into both of those. So that's my new value of K. Now we rewrite our formula. So the Earth equals 25/4 times the moon. And now what do we want to find? Now we want to find the weight of this dog. So how much would a 50-pound dog weigh on the moon? So what do we know? We know the dog weighs how much on Earth? Okay, on Earth, the dog weighs what? 50 pounds, right? So plug that in and solve it. And we can easily solve this just by multiplying by that 4. That's going to clear that out. Cross multiply either way. We'll just multiply it all by 4. That'll clear that out. And what does that give me then? That gives me 4 times 50. That's going to be now 200. And that equals 25 times the moon. We'll divide by our 25. And how much should that dog weigh on the moon now? On the moon, that dog is only going to weigh now what? 8 pounds, isn't it? Right? Because 200 divided by 25, that comes out to be 8. So that dog on the moon would weigh 8 pounds. So we build our equation, we find our K, we plug the values that they give you back in, we figure out the new value. And they're all pretty much the same. These are direct, meaning it's multiplication. Whenever I see the word direct, that means we multiply. We'll look at one more, and then we'll look at inverse variation. So we'll do one more direct variation, and then we'll look at inverse variation. Question 33. If you take a physics course, you'll work a lot with springs. How far a spring stretches is based upon the type of material of the spring. And so you can find that K, and then you can figure out how far the spring should stretch based upon different weights. So this is called Hooke's Law. If you take a physics or a physical science class, you're probably going to have to work a lot with Hooke's Law. And Hooke's Law states this: the distance a spring stretches varies directly as the force applied. So let's take that piece out. What do we have? Distance varies directly as the force applied. So what's our formula look like there? Distance equals K times the force applied. Right? Distance equals K times the force. Now, what do we know about this particular spring? If a force of 15 pounds stretches the spring 8 inches. So the force is 15. Distance of the spring stretches is 8. That gives us then 8 equals K times that 15. We will divide by our 15 here. Now we know our K is going to be 8 over 15. They're really not hard to do. It's just a matter of setting them up. Direct variation means they multiply. So whenever I see direct variation, that means I have to multiply. Now, what's our formula look like? Distance equals 8 over 15 times the force applied. So, what are we now going to find? It says, how much will a force of 30 pounds stretch this spring? So now we want to change that force, and we want to change that force to be 30. So we plug it in. And the distance is going to be 8 over 15 times 30. I'll make that 30 over 1. So you can see what happens pretty easily here. 30 and 15 cancel. That leaves you with a 2. And so that comes out to be 16. And that spring isn't going to stretch 16 inches. And you can label these however you would like. If you want to use X's and Y's, you can do that. But I found in years past, students get confused with X and Y. They don't remember which one is which. So if we use words, we're a lot less likely to get confused. So that was direct variation. And direct variation means that we multiply. Now, inverse variation means you divide. So direct variation, that means we multiply. And inverse variation, well, that means we divide. So inverse variation looks like this. Y equals K over X. So instead of multiplying, when it says inverse, we divide. Now it can also be inverse to a power as well. But the main premise is whenever you see inverse, divide. Direct, you multiply. Build your equation, plug the values in, find the K, answer the question. 36. This is again on page 417. We're going to look at question 36. It should be 417. Yep, because we're at 417. We're looking at variation, so 417. We're going to look at question 36. Now, when I read this one, the key words I pick up on are either inverse or direct variation. So the weight of an object varies directly as a square of its distance from the center of the earth. So the weight of an object varies inversely. That means we divide as the square of its distance to the center of the earth. So what's our formula going to look like? It's going to look like this in a way. So we've got the weight, okay? It's going to be here. And what does the weight equal? Well, the weight equals K, that's our constant that we have to find, over the distance, but in this case, it's the distance squared. So there's your formula. weight equals k, which is the constant value, over the distance squared. Is everyone okay with how I got that? Right? Why am I dividing? Because it says inverse. Inverse means we divide. Direct means we multiply. Now, why is it over the distance squared? Because it says here, varies inversely as the square of its distance. So that's why that piece is squared. Now, what do we know? The distance from the center of the Earth. If the object is 8,000 miles from the center, weighs 90 pounds. So that distance is going to be 8,000 pounds. Okay? And the weight is 90. So we plug in our values, and we find our k. So 90 equals now k over 8,000 squared. The values get really large, and that's okay. So we have our 8,000, and we're going to square that 8,000. So we've got 90 equals k over 6, 4. Looks like 1, 2, 3. Okay, and 0, 0, 0, 0, 0. Okay, so there it is, right? And how do we find our value of k? We just simply do what? We just simply multiply. So now we've got our value of k. So we'll take that, we'll multiply that by 90. And it looks like when we multiply by 90, we get this. It's going to be a huge value, and that's okay. Now it looks like 1, 2, 3, 4, 5, 6, 7 zeros. 7 zeros and a 576. Right. And that's fine because that value is going to be large. Rewrite our formula. So now we know our weight. Rewrite our formula is going to be, and you can use scientific notation if you want. That's perfectly fine. If you would rather use scientific notation and you're comfortable with that, not a problem at all. And that's going to be over the distance squared. So there's our formula. Right, like I say, if you want to use scientific notation and you want to write this as, 5.76 times 10 to the 9th power, you can do that too. It doesn't really matter. So scientific notation's fine. Standard notation's fine. So that's our formula. Now, what are we looking for? We're looking for the same object, but it's been moved now 12,000 miles from the center of the Earth. So its new distance is going to be 12,000. So we'll plug that in, and we'll find our new weight. And don't forget to square the 12,000. And I know the numbers are large, but you can use a calculator. And I've already got that in my calculator here. So that's what we had before. We're going to now divide that by our 12,000 squared. And that's going to give us our answer then of 40. And so that object will now weigh 40 pounds. This is what you'll be doing in a physics or a physical science class. As you move further from the center of the Earth, you weigh less. That's why in outer space, you're further away from the Earth's pull, and so you weigh less, right? And on the moon, your weight is less than on Earth because the moon is smaller, right? It has to deal with the mass. So gravity deals with the mass. So the further you are from the center of the planet, the less you will weigh. in most cases, it's not that big of a deal. It doesn't change much because it's over that distance squared. Right? When you fly in an airplane, the distance from the center doesn't change much at all in the grand scheme of things, so your weight still stays the same. And if you're going up in the atmosphere, you might weigh a little bit less, not much. But if you go into outer space, you're further from the Earth, so your weight is actually less. But if you take a physics course, you'll learn how everything relates to each other. This is basically physics. Let's do another one. How about we look at question 38. 38 is another inverse variation. The illumination produced by a light source varies inversely as the square of the distance from the source. The illumination of a light source at 5 meters is 70 candelas. What is the illumination 12 meters from the source? So what happens as we move further from away from the light source? Okay, the light is not that bright, right? Further we are away from the source, the less we see the light. So that's why it's an inverse variation. Further you are away from the light, less is visible. So let's set up our formula. And what's our formula going to look like? It's an inverse variation. We were looking at illumination, and this is question 38 here. So we've got illumination, and that varies now inversely as the square of this distance. So K over that distance squared. So there's our formula. So the illumination is going to equal K over the distance squared. And we have a light source at 5 meters, 70 candelas. So the distance is 5. Illumination is 7. Fill it in, find our K. And don't forget, it's not 70 over 5, or sorry, 70 equals K over 5. It's 70 equals K over 5 squared, which is 25. Okay, there's our formula. Now, we can finish this very easily by doing what? By just cross multiplying. When we cross multiply, what's our K? When we cross multiply, we have 70 times your 25. So K now comes out to be 1750. Write up our formula, and we're almost done. So 1750 over the distance squared. And what are we going to plug in for our distance now? We read this, it says, what is the illumination 12 meters from the source? So we're going to be plugging in a distance of 12. So plug in your 12, and that's going to be then 1750 over 12 squared, which is then 1750 over 144. Which then comes out to be, if we round here, and you can round on these, we'll just take this out to, let's say, 2 places. So if I take this out to 2 places, it looks like it comes out to be, let's make sure we did it correctly here. We've got our 1750, divide that by 12 squared, and it should come out to be about 12.15. and that's candelas. And you can leave that as a fraction, or you can use a decimal for your answer. And so that's going to be in candelas. And that's just the way we measure light. They kept the fraction. We broke it down. It's the same thing, though. So we cross-multiplied. We got our answer there. Then we plugged in our distance of 12 and solved out, and we got that. So 1750, divide that by the 144. Yep, and that comes out to be that. Okay. All right. So now let's look at joint variation. And joint variation is where all the pieces go together. So when we talk about joint variation, that just means we have multiple parts going together. They can be dividing, they can be multiplying. Bless you. So when we talk about joint variation, we have multiple parts. So multiple parts or multiple variables. Now, again, direct, what does direct mean? Direct means we multiply. Inverse means we divide. So when we set this up, we may have several parts working together. They may multiply, some may divide. It might be a square involved. And we have several pieces going together. Question 40. And this again is on page 417. So question 40. And this is on page 417. This one is joint variation. The volume of gas varies inversely as the pressure and directly as the temperature in kelvins. So, what do we have? Volume. And how does it relate to the pressure? Inversely, directly to the temperature. So what's it going to look like? What do we have first? First thing we have is volume. And your volume is going to be K. That's our constant. Okay, and it says it varies what? It varies inversely as the pressure. So that means the pressure goes below. And directly as the temperature. So the temperature goes on the top. So that's our formula. So the volume is going to equal K times the temperature, because that's direct variation, divided by the pressure, because that's inverse variation. Now we fill our parts in, and what do they give you here? It says if a certain gas occupies a volume of 1.3, at 300 K, so that's Kelvin, that's temperature. It has a pressure of 18 newtons. So fill in our formula. So we've got 1.3, that's our volume, equals 300 K over the pressure, which is then 18. Go ahead and multiply, and we'll just cross multiply. We've got decimals, so we'll just be able to use the decimals here. So go ahead and cross multiply. And that is now 1.3 times your 18. That's 23.4 equals 300 K. We'll divide by our 300. And what does K now come out to give you? 23.4. Divide that by our 300, and that gives you a K of 0.078. Write up our formula. So volume now is going to equal 0.078 times the temperature divided by the pressure. Okay. Now, what values do they give you? It says, now we want to change it. So it says find the volume at 340 K, so that's 340 Kelvin, that's my temperature. And a pressure of 24 newtons. So we change the temperature and we change the pressure. That's going to give me a new volume. Plug our values in, calculate out our new volume. And calculate all of that out, and let's see what we get. So multiply that by 340. That's my new temperature. Divide that by our 24, and that comes out to be 1.105, and that's going to be in terms of liters. Let's look at another one. Like I said, they're all kind of the same, but a little bit different. Let's look at 47. Body mass index. The federal government has developed the body mass index, the BMI, to determine the ideal weights. A person's BMI is directly proportional, that means multiply, to his or her weight in pounds, and inversely proportional to the square of his or her height in inches. So let's write up our formula. BMI is going to vary directly to the weight, right? So K times the weight. Inversely proportional to the square of his height. So we've got to square that height there. So this is how we work with BMI, right? When you look at your BMI, that's your body mass index, which a lot of you are probably familiar with. What are two things they have to take into consideration? How tall you are and how much you weigh. So what happens as your weight goes up? Your body mass index also goes what? Up, right? The more you weigh, the higher your BMI is. What happens the taller you are? If your weight stays the same, but if the person's taller for the same weight, what's their BMI going to be? Less, right? That's why it's inverse. So directly means we multiply. Inversely means we divide. So as you increase the weight, body mass index goes up. As you increase the height of that person and the weight stays the same, BMI goes down by the square. And that's in terms of inches. So let's see what we have. Okay. A BMI of 19 to 25 corresponds to a healthy weight. A 6-foot tall person weighing 177 pounds has a BMI of 24. Now we have to be very careful with the height. Height has to be in terms of inches. So let's see what we have here. 6 foot tall person. That needs to be in inches. So always watch your units. If that person is 6 foot tall, in inches that would be 6 times 12, right? 12 inches in a foot. And we'll multiply those together. And that gives us now 72. So that's our height. So the height is 72. And that's going to correspond to someone weighs 177 pounds. So the weight's 177. And your BMI of that person is 24. So let's go ahead and find our RK. So plug our values in. So we've got 24 for the BMI, unknown value K, that's our constant. The weight is 177, so it's 177K over 72 squared. So let's rewrite this again. It's 24 equals 177K over 72 squared, and 72 squared is 5184. And we'll just put that over 1. Cross multiply and quickly solve this out. So we'll take that times our 24 here. And that gives you 124416 equals 177K. And we'll divide by our 177. And we now have found our K. And our K comes out to be 702. And we'll take this out 2 places. It's going to be more than enough. How about 92? Close enough. So we have square, cross multiply. Looks like that's our K. Now, K can be a different value for men or women, right? Because they have a different way they're calculated. They're done the same way, but the K is different. Because this might be the K, this K might be the value for a man. A woman's K might be different, might be more, might be less. So now let's rewrite our formula. BMI equals now 702.92 times the weight. Divide that by the height squared. So now we can calculate a new BMI. So now we have a new person coming in. And that new person weighs 130 pounds, height of 66 inches. So the weight is 133. The height is 66. Plug our values in and calculate it down. And let's see what our BMI is. Plug in our values. It's going to be 702.92 times 133 for the weight. Now the 66 is already in terms of inches, so that's already been converted down. And this person should have a pretty low BMI because their weight is so low. 2 and times that by 133. Divide that then by 66, but don't forget you have to square it. If you don't want to forget to do that. So we've got to square that 66. And that comes out to be a BMI of 21. And it says round to the nearest whole number. So we're going to go ahead and round this to 21. So that person's BMI should be 21. Why is it so low? because of the weight, right? A little bit shorter, but not a lot. The main thing with the BMI is going to be the weight. As you increase your weight, your BMI goes up. As the height goes up, your BMI goes down. That's why they're inverse. That should now let you get through your homework. So I'm going to go ahead and pass out the sign-in sheet. And then I have some extra things to pass out as well. So let me go ahead and pass out the sign-in sheet here. Sign-in sheet. Does everybody have the new homework packet? Yep, everybody came in, has the new homework packet. All right. So I know several of you, not so much in this class, but in my next class, are going to have to leave early and take the final exam early. And so I went ahead and made up the practice final and the answer key for it. Now, it's not due until the last day of class. Some of you might be leaving early, right, because you have to catch a flight to go back home, and that's fine. I've signed a lot of those papers. Here, though, is your take-home and your practice final. You can go ahead and start working on it now. If you're not leaving early and you're coming back after the Thanksgiving break, then we'll spend time in class going over this. But if you're leaving early, at least you have it now so you can go ahead and get started. We're not going to have another exam except our final. So our final will be the last exam in the course. I'll go ahead and pass this out. I've got this plus the answer key. So if you're leaving early, if you're leaving after the Thanksgiving break, you can go ahead and start working on this now. If not, you just hold on to it, and you can work on it towards the end of the course. There are some things that we haven't covered yet, and we'll be covering them in the next couple of weeks. But if you're leaving early, this will happen. Now, there's a practice final in this packet, and there's also a take-home final. You'll also have it in class. You're welcome. So if you're leaving early, you need to catch a flight back home and you have to leave early, you've got this to work with. Hopefully you're doing that. I am. Yeah, I was worried about you there for a minute. So. And the next part I've got to pass out is going to be the answer key for it. And again, I'm just giving it to you early. This way you can start working on it if you want. If you're staying and coming back after the Thanksgiving break, we will go over this in class. We'll make sure that we cover it. If you're leaving early, though, at least you've got now the final exam to start working on. This is the answer key for the practice final. And behind that practice final is a table. So make sure that you sign that sign-in sheet. I will see everyone then on Thursday. Sure. Final will be worth 300. I do give you a take-home one, and that's in that packet. That helps you get ready for the final. When I give you the final, I'll cut it down to 30 questions. You'll have 2 hours to do it, which you should have plenty of time. You'll know what's going to be on that final. If you study that practice final, it's just like all the other exams. If you study the practice final, you will know what's going to be on that final. And work on that take-home final. That'll improve your grade as well, and you'll do fine in the course. Now, the only reason I'm giving it to you so early is I know several of you are leaving early. Several of you are not coming back after the Thanksgiving break. So, before you leave, we'll have to find a time, if you're leaving early to go home, for us to work together to take your final. All right, so if you're leaving after that Thanksgiving break and going home and not coming back,